Welcome once again to Symbolic Logic. I'm Mark Story. We're at Bellevue College. What we're going to do this time around is take a look at and see how doing a natural deduction proof looks. You've already studied this in class. You've got plenty of practice problems and examples in your text. But just in case you need to see how it's done, see what it looks like, let's do it one more time for the video. Here's an example of a proof. And at this stage of the game, all we're dealing with is valid arguments. That's all we're going to see. And the way they're going to look is to be written out from now on for natural deduction. They'll be written vertically. So we'll have all the premises written vertically. After the last premise, just by convention, we'll have a slash and put the conclusion. So it looks a little different than truth tables, but you'll get used to it. And this is the way it's going to look for the rest of the quarter. So in this case, we have 4 premises. Sometimes you have 1, 2, 3, 4, 5. This time we have 4. It's a valid argument. We should be able to use these premises and the rules we've learned to derive or get the conclusion. Somehow, if we manipulate the premises, the conclusion should pop up. And once it does, we're done. We've proved the argument's valid. We've proved if the premises are true, the conclusion will be guaranteed. So at this stage of the game, we might have 4 rules available to us: modus ponens, modus tollens, disjunctive syllogism, hypothetical syllogism. You're familiar with those, but let's see how it works here in this proof. What we'd want to do is just take a look and see if we can find some kind of pattern. For instance, we might see that if we use lines 1 and 3, that would be a modus ponens pattern. So what we do is we write down, for the next line, we write down what modus ponens would give us. If A is true, and if A is true, then G horseshoe D would be. So modus ponens would give me G horseshoe D. And what I write is line 1, comma, 3, MP, the abbreviation for modus ponens. Now this is picky. I mean, you can't imagine how picky I'll be with this, but technically you have to have that comma there because you're not appealing to line 13. And then you're appealing to this particular rule. This justifies our saying this is true. That is, if these 2 lines are true, modus ponens tells me this must be. But what are we going to do with that? I don't even know yet. Let's just continue to see if there's other things that might happen. For instance, I noticed that line 2 and 4, I can use them together to do a disjunctive syllogism. What would that give me? Well, either B is true or D horseshoe S is, but B is false. Therefore, it looks like D horseshoe S must be. So I can write that down. And again, I'm appealing to lines 2, in this case 4, in this case disjunctive syllogism. It doesn't matter if you write 4-2 or 4, 2 or 2, 4, but you're appealing to those 2 lines. Well, that's still not my conclusion, so I need to continue on until I get this. This is my target, my goal. But I notice lines 5 and 6, I can do hypothetical syllogism on it. 5, 6, hypothetical syllogism, and that gives me exactly what I'm looking for. At this point, I'm done. It's actually as easy as that. We just use these premises and the rules we have available to us to manipulate the premises, change them around until the conclusion pops up. Once the conclusion pops up, we're done, and we've proved that if the premises are true, the conclusion is guaranteed. And this may not get you a free drink at a bar, but it gets you a problem done on a test, and this is a good thing. So give it a go.